Bismillahirrahmanirrahim. In this lecture, I am solving problem 3.125 from the book Thermodynamics and Engineering Approach by Cengel 7th edition. So, statement of the problem is a 0.5 cubic meter rigid tank. This is 0. This is basically this one is the 0.5 meter cube rigid tank containing hydrogen at 20 degrees centigrade and 400 kilopascal. So first I am writing given data. So initially volume of this tank is a 0.5 cubic meter. Rigid tank means the volume of this tank is fixed. Containing hydrogen, working fluid here is hydrogen. At 20 degrees centigrade, initially temperature is 20 degrees centigrade. We will use perfect gas equation, so convert this to Kelvin, which is equal to 293 Kelvin. And pressure is P1 is equal to 400 kilopascal. So convert this into Pascal. So 400 kilo value is 1000 Pascal, which is equal to 4 lakh Pascal. Is connected by a wall. This is wall. Is connected by a wall to another 0.5. The volume of this is also 0.5 meter cube. This is V2. 0.5 cubic meter. Rigid tank. This is also rigid. Volume is fixed. That holds a hydrogen. Here the temperature of hydrogen is T2. Working fluid in both is hydrogen 50 degrees centigrade, which is equal to 50 plus 273 Kelvin. So T2 is equal to 273 plus 50 is 323 Kelvin. And pressure is 150 kilopascal in the other tank. In this tank, P2 is equal to 150 kilopascal. Convert this into Pascal. So 150, the value of kilo is 1000 Pascal, which is equal to 1,50,000 Pascal. Now the wall is open. After this, the wall is open. This wall is open. So after opening the wall, the hydrogen of both will be mixed, and the system is allowed to reach thermal equilibrium with the surrounding. After some time, it will reach into thermal equilibrium. It means the heat will transfer from high temperature body from second to faster. And after some time, the temperature of both tanks will be equal, and this is called thermal equilibrium with the surrounding, which are at 15 degrees centigrade. Final temperature after gaining equilibrium, TF. Final temperature after gaining equilibrium is equal to 15 degrees centigrade, and this 15 degrees centigrade is basically equal to 15 plus 273 Kelvin, which is equal to 288 Kelvin. So final temperature will be equal to 288 Kelvin. Now determine the final pressure in the tank. So this is final temperature. Now find the final pressure. So to find final pressure, we will find total mass, total temperature, final temperature, total volume, and then we will use PV is equal to MRT formula to find the final mass. So first I am finding the value of R. This is required, and assumption is hydrogen is a perfect gas. So we will use perfect gas equation. So in solution, as we know that R is equal to molar gas constant divided by molar mass. This R is basically molar gas constant, and this is universal constant. Universal mean this is constant for all gases, and M dash is basically molar mass. So R is equal to universal, the value of universal gas constant is basically 8.314 joule per mole per Kelvin, and the value of molar mass per hydrogen is 0.002016 kilogram per mole. So this per mole will be cancelled with this per mole. Final answer will be joule per kilogram per Kelvin. So R will be, simplify this, so R will be 4124 joule per kilogram per. Now we have to find total mass. So for total mass, first I find M1 and then M2. So from ideal gas equation, M1 is equal to P1V1 divided by RT1. So the value of R is P1 is 4 lakh Pascal, and Pascal is equal to Newton per square meter. Multiply by the value of V1 is 0.5 cubic meter. V1 is basically the volume of the first tank. R is 4124 joule per kilogram per Kelvin. Joule is basically equal to Newton meter per kilogram per Kelvin. And to the value of T1 is 293 Kelvin. So here this Kelvin will be cancelled with Kelvin, Newton will be cancelled with Newton, per meter square and per meter, this will be meter cube, this will be cancelled with this meter cube. Now simplify the value and the answer will be in kilogram. This is per kilogram, mean in double division it will be in numerator. So mass M1 is equal to 0.1655 kilogram. Now we are finding M2. So M2 is equal to, according to ideal gas equation, P2V2 divided by RT2. P2 is 150,000 kilopascal. 150,000 Pascal. Pascal is equal to Newton per square meter. The value of V2 is also the volume of second tank is also 0.5 cubic meter. The value of R is 4124 joule per kilogram. Joule is equal to Newton meter per kilogram and per Kelvin. The value of T2 is 323. This is available in the given data. Kelvin will be cancelled with Kelvin, Newton with Newton. Per meter and per square meter is per cubic meter. So per cubic meter will be cancelled with meter cube. So per kilogram will be in numerator in double division. So M2 will be equal to 0.0563 kilogram. Now total mass is equal to M1 plus M2, which is equal to 0.1655 kilogram plus 0.0563 kilogram. So total mass, add these two values, so total mass will be equal to 0.2218 kilogram. Now total volume, when we open the wall, then the total volume will be volume of first tank and volume of the second, because the hydrogen will be mixed with each other and it will goes to thermal equilibrium. So total volume is equal to V1 plus V2. V1 plus V2, which is equal to 0.5 cubic meter plus 0.5 cubic meter. So total volume is equal to 1 cubic meter. And total final pressure temperature is given to us. So we can use final pressure by using the formula. So final pressure is equal to PV is equal to MRT. So MT total mass, R is constant per hydrogen, and final temperature divided by total volume. PV is equal to MRT. So with the help of this formula we will find final pressure. So total mass is equal to 0.2218 kilogram. The value of R is 4124 joule per kilogram per Kelvin. Joule is equal to Newton meter per kilogram per Kelvin. And to final temperature is 15 degrees centigrade, which is equal to 288 Kelvin. And total volume is 1 cubic meter. So final pressure will be, multiply these three values and divide by 1. So this will be equal to 263,434. And now calculate the unit. So this kilogram will be cancelled with this kilogram. Kelvin will be cancelled with Kelvin. 1 meter will be cancelled with 1 meter. This is Newton per square meter. Newton per square meter. And Newton per square meter is basically equal to Pascal. So convert, this is the answer. If you want to convert into kilopascal, so divide by 1000. 263,434, and this is Pascal. So multiply and divide by 1000. So multiply by 1000. This is kilo. Kilo is equal to 1000 and divide by 1000. So PF is equal to, final pressure is equal to 263.434 kilopascal. So this is the answer and final pressure of the tank. So for more problems, please like and subscribe my YouTube channel and share with your friends. Thank you.